Hello everyone, I hope you all are fine. So today we will start with our hydrogen chapter. So hydrogen, it is having symbol H in the molecular form. It exists as H2, that is hydrogen molecule or hydrogen gas. It is having atomic mass 1 and atomic number is also 1. Both atomic mass and atomic number, they are equal to 1. Now hydrogen, it is having electronic configuration 1 and 1 electron it is present in the K shell. Hydrogen, it is a flammable gas, and hydrogen element, it resembles different elements, like it resembles the first group elements as well as it resembles the 17th group or 7A group elements of the periodic table. Still, the position of hydrogen in the periodic table, it is not fixed, it is anomalous. So we will study first of all its relation with different elements, that is with alkali metals as well as with the halogens. So first of all, if we compare hydrogen with respect to the alkali metals, so we know alkali metals, they are the first group elements starting from lithium, then afterwards sodium, potassium, rubidium, cesium and francium. We know what they do have common. They all belong to first group and they have one electron in their outermost shell. Similarly, hydrogen also, we know it is having one electron. So one electron present in the alkali metals as well as one electron in the particular hydrogen. Next one, it is with respect to valency. If we check out the valency of alkali metals, so of lithium, sodium, potassium, rubidium or other elements of alkali metals, their valency is 1. Here hydrogen is also having valency of 1. After that, if we compare the electropositive character means how much positive charge does these elements they develop after loss of electron. So alkali metals, they acquire one positive charge. Similarly, hydrogen on loss of one electron, it acquires the one positive charge. So again there is similarity. Then after that, alkali metals, they form different compounds, like when alkali metal combines with oxygen. So generally the compound formed, they are in the form of like two alkali metals, they are combining with one oxygen atom. So formula is journal Li2O, or we can call M2O. M here it is like a journal metal, anyone from this one. Similarly, when hydrogen it combines with oxygen, it also forms, what does it forms? It forms again the same type of compounds having two hydrogen atoms and one oxygen atom. So again there is similarity. After that, alkali metals, they are also reducing in nature, that is they lose their electrons whenever they combine with any electronegative element. Similarly, hydrogen also, it loses one electron. So alkali metals and hydrogen, they are the reducing agents, means they itself, they get oxidized but they reduce the other elements. So these are the general characteristics with respect to the alkali metals and hydrogen. These are the similarities on the behalf of which alkali metals and hydrogen, they share the same particular group, that is group number 1. But hydrogen, it also has its relation with group 17 elements. So group 17 elements, which are those? It starts from fluorine, then chlorine, bromine, iodine and astatine. So fluorine, it is having electronic configuration 2,7, chlorine it is 287 and so on. Similarly, hydrogen, we know it is having one electron only in the hydrogen atom and only one electron is present in the K shell. Now you can see here fluorine, it is having how much electrons less than the nearest noble gas? Nearest noble gas to fluorine, that is next 10th element, that is neon. So neon, it is having 2,8, so only one electron difference is here. Here also in case of hydrogen, next one is helium, so only one electron difference is there. So we can say these share again the same similarity. After that, Just like alkali metals, they were strongly electropositive, and hydrogen was also showing the electropositive character when it was combining with electronegative element or with the non-metals. So here, this one, chlorine or fluorine, it gains electrons. Like when chlorine atom gains electron, it gets converted to chloride ion, like in the formation of sodium chloride. So sodium is Na positive and Cl negative. So hydrogen also shares the same property. It shares the tendency with the group 17 elements to form the electronegative ion, that is hydride ion. This one is known as hydride ion. So again the property is same. After that, then first one we discussed valence electrons. After that we discussed its property, that is this one, particular formation of electronegative ion. After that, the valency we know all the group 17 elements, they have valency is equal to 1. Similarly, hydrogen also, it is having only one difference from the nearest noble gas, so its valency is also 1. After that, all these elements, they exist in the form of diatomic particles, that is like F2, Cl2, Br2, they all are diatomic, their molecules are diatomic. Similarly, hydrogen is also diatomic. We know hydrogen exists in the form of gas, that is H2. So these are some properties, but still the position of hydrogen, it is not yet fixed. There is uncertainty that whether it particularly belongs fully to first group elements or it belongs to the group 17 elements. After that, next one is the preparation of the particular hydrogen gas in the laboratory. The preparation is generally carried out by a process that you had studied earlier known as Bosch process. But before that, we will study about some simple preparations that they also lead to the formation of hydrogen, but practically they are not preferred. Either in some case the reaction is very vigorous, or it is very exothermic, or sometimes the cost that doesn't manage up, or we can say the availability of the raw materials is not possible. So several reasons are there. So generally the method employed is Bosch process, but first of all we will discuss with the very reactive elements, like the elements which undergo the displacement reaction very easily, like when potassium, which is an alkali metal, when it is treated with water, it is cold water. When potassium is mixed in cold water, what happens? There is formation of potassium oxide followed by formation of potassium hydroxide, and there is large amount of heat produced. The reaction is exothermic, potassium starts burning and hydrogen gas is liberated. So this reaction is not preferred for preparation of this hydrogen because it doesn't suits the applicability, and moreover due to large liberation of heat it may destroy the vessel also. So this method is not preferred. In exams there may be questions like when potassium burns, what type of flame or which type of color is there, so that you need to keep in mind. After that, the next one, it is with respect to the reaction of water with sodium. So again this reaction is very much vigorous. It again leads to the formation of hydrogen, but again this reaction exothermic in nature, so doesn't applicable because it may also destroy the vessel. After that, reaction of some less reactive metals like calcium, when it is treated with cold water, so no reaction is there when cold water is there, but when calcium it is reacted with hot water, then there is immediate liberation of hydrogen gas which burns with a pop sound. So this one is preferred. Similarly, the reaction may be carried with magnesium also. When magnesium it is added to water, there is liberation of hydrogen along with formation of magnesium hydroxide, and magnesium oxide may also be found in some cases, but after reaction with water it gets turned to magnesium hydroxide. After that, the next one is the reaction of iron. So all these reactions you need to read. And what are the observations? The observation is simply liberation of hydrogen, or there is formation of some specific color, like lilac flame it is observed in the case of potassium, then yellow colored flame it is seen in case of sodium, and so on. So different particular elements they combine. How do they combine? One series I am going to write here. For that, in order to learn that series, one simple trick is there, like please stop calling me a careless zebra, instead try learning how copper saves gold. Please stop calling me a careless zebra, instead try learning how copper saves gold. So for P it is potassium, symbol is K. For S sodium, symbol is Na. For C it is Ca, calcium. For M it is magnesium. For A it is aluminium. For C it is non-metal. Here you can add this one, or you can also skip this one, but in the normal reactivity series carbon is included. Then Z for zinc, I for iron, that is Fe, try tin, that is Sn, L lead, Pb, H, that is very important, hydrogen. And after that copper, you know, it is Cu, then silver it is Ag, and gold it is Au. So this one is a general trick to remember the activity series. Just keep in mind the elements which are above the hydrogen, they are more reactive and they can easily displace the hydrogen from any dilute acid or from the water, while the elements which are below, these only three are below, so these will not displace the hydrogen from any of the dilute acid or from the water. So these are known as very noble metals or very less metals, and they do not evolve the hydrogen. Rest all the elements they give out the hydrogen, but condition is as you move at the top reactivity increases, as you move down the reactivity declines. So this is the basis. We were discussing the reaction of elements, metals with water in order to liberate the hydrogen. After that, the next one is the reactivity of iron with water. So reaction of iron with simple water, it does not occur. With normal cold water it doesn't occur, but when water is boiled and steam is formed, then a reversible reaction occurs which leads to the formation of hydrogen along with oxide of hydrogen, that we call as triferric tetraoxide. So this one is very much important. This question could be in your balancing part, balancing reaction. So this thing you have to keep in mind. Okay, so reactivity series, please keep in mind, this one is very much important.